This
power,
conference will now be recorded.
gamma technologies is there, then boost, that is our AVL fire, and I am focusing in this diesel RK that is available in internet, so there is no need to purchase also. So today we discuss the what are the history and other things. I have take one case study also for the result and discussion part for this related to diesel RK. Okay, next. So in this content of the presentation is introduction of this diesel RK, then history, then application, validation. Basically, I am doing this validation. There are two types of validation. The first one is I am doing some experimental with experimental setup, that is our MFVCR, multi-fuel variable compression ratio, and then validate with this diesel RK. And the second validation is I was taken this some previous research paper experimental data, and that experimental result data I have validated with the our this diesel RK with the help of this diesel RK. Then some mathematical equation which is related to this diesel RK software. And then there is a three characteristic, as we know that there are mainly this performance, combustion, and emission parameters in the CI engine, and then resultant discussion and conclusion and the reference. So next, in the introduction, basically there is an increasing interest in the application of various alternative fuels in marine diesel engines, including methanol and ethanol. So one of the challenges in the relevant research is the development of computer codes for simulation of the dual fuel working process and engineering optimization of engines. So the mathematical model is described which simulates a mixture formation and a combustion in an engine with a dual fuel system, in which basically this methanol is used as a main fuel and the pilot portion of diesel oil is injected in to ignite methanol. So the development of this combustion model for this diesel RK was incorporated into the existing engine full cycle thermodynamic simulation tool. So basically this is related to our thermodynamic simulation tool. So the development, this combustion model includes the self-ignition delay calculation, sub-model based on the detailed, no, it's previous slide. So sub-model based on the detailed chemistry simulation of methanol, pre-combustion reactions, sub-model of evaporation of methanol droplets, and the sub-models of the methanol fuel spray penetration. Then there is a spray angle is also there, and the droplet forming is there. So these are the mainly we are focusing when we are doing this diesel RK. So the development of this computer codes allow the engineers to account for the arbitrary shape of the combustion chamber. So additionally, if we have to take each fuel system may include several injectors with arbitrary oriented nozzles with different diameters and central and in the combustion chamber. So the fuel spray evolution model consists of equations with dimensionless parameter to account for fuel properties and in-cylinder condition. So specifies of injection pressure profile and interaction of sprays with the air swirl and between themselves are also considered in this software. So the model allows engineers to carry out rapid parametric analysis, and the result of modeling for a medium speed dual fuel diesel engines are presented. And this is a good agreement between calculated and experimental heat release rate curves and integral engine data also. So in the each fuel spray is split into a number of specific zones with different evaporatant zones. These zones are formed on the cylinder liner surface and on the cylinder head, and this is also taken into account. So the piston bowl in the modeling process is assumed to have an arbitrary axisymmetric shape. So the combustion model support central, non-central, and side injection system. So this in this the basic NOx calculation is very important for this the diesel RK model. So in this 199 reactions, and that is I think most of the 33 species equations is also there. So those are the For emission point of view, the soot formation calculation submodel used is one of the most important parameter. So the ignition delay period is estimated using relevant data in the pre-calculated comprehensive, that is our 4D map of ignition delay. This 4D map is developed using Chemkin detailed chemistry simulation. So there is a one chemical chemistry simulation is there. So it is also taken account the effect of the temperature, the pressure, air fuel ratio, and the EGR, that is our exhaust gas recirculation. So above this submodel, we are integrated into full cycle engine simulation software together with library of non-linear programming procedure. That is our allowing multi-dimensional optimization of diesel engine. So this is the main, other than this list of optimized parameters, this include compression ratio, EGR, injection profile shape, and fuel injection pressure, then mode timing, boost pressure. So these all parameter we have to do using the software optimized. So in this research, there was done an optimization of working parameter of medium speed diesel engine at few operating parameters with account of weightage coefficient of the point. So for this common rail pressure turbocharger assist for locomotive performance were obtained. So in this diesel RK, this is the second slide. This one, the program can be used. So basically, diesel RK is a full cycle thermodynamic engine simulator software. One is designed for simulating and optimizing working forces of two and four stroke IC engine with all types of boosting. So the program can be used for modeling the following types of this engine. That is our diesel engine, including PCCI and engines fueled by biofuels, uh, spark ignition petrol engines, and SI gas engine, including three-chamber system, and engine fueled by different gases, methane, propane, biogas, wood gas. Other than this, also a lot of we can do. Then there are dual fuel engines, that is engines having few independent fuel injection systems for different engines. Uh, Other than this, this diesel RK is a thermodynamic tool, which are considered as open thermodynamic systems. That is our representative. Other than these applications, also this fuel consumption prediction and optimization. Then there is a knock prediction also, torque curve and other engine performance prediction is also there. Then exhaust gas recirculation and optimization, and turbocharger and bypass matching and optimization, conversion of diesel engine into gas engine, and cooperation with different modeling tools. These are the main application which we can do with the help of this diesel RK. Yes, next slide. So before going to this uh, history or application point of view, as I told you, this fuel consumption prediction and optimization is there. So the main features of this program, uh, this digital RK, are similar to other known programs like your Wave Ricardo software. It is there. And Gamma Technologies GT Power, the short form is GT Power, and this Boost AV1. So in this, however, together with conventional abilities, this program, this diesel RK, has new advanced feature also, like your fuel spray visualization tool. Then your it is a multi-zone fuel spray mixture combustion model. Then one-dimensional and two-dimensional parametrical researches procedure is there. And for your multi-parametric and multi-dimensional optimization of engines parameter, that is our NOx, soot, uh, then SFC, specific fuel consumption. It may be calculated as inside, and then diesel RK with the user defined procedure, and it is linked with the diesel RK kernel. So next. So basically there are three types of category. Uh, as we know that this CFD, computational fluid dynamics, in this, if you are doing this engine problem, that is our piston cylinder arrangement, in this we have to use dynamic meshing. So dynamic meshing, it is changing with respect to time. So it is better we can do in the diesel arc, because in CFD it will take maybe 1 week also for completion of one simulation. And for that we have to at least a good workstation. Otherwise we can't do in our laptop or in our desktop. It is very difficult to do in the CFD. So although the CFD possesses the ability to simulate all fluid flow and heat transfer or chemical reaction phenomena, but in practice when we are going to the IC engine, it is some limitation is there. So what are the some limitation? The limited capability of current computers to handle small scale phenomena in an acceptably short time. Then second, the inadequacy for current scientific knowledge about turbulence, two-phase flow, and the chemical reaction, especially when all the three are simultaneously presented. So it is very difficult to do in the CFD also. So this attempt to optimize diesel engine process by way of pure CFD cannot be succeeded at present. So the choice of the thermodynamics engine model together with quasi-dimensional multi-zone model of combustion accounting of conventional and diesel combustion is conditioned by requirements of high accuracy and high computational speed, because the number of engine simulation session is optimization over the whole operating range comes up to the few thousands. So the earlier some of the published paper for in the area of this multi-zone diesel spray combustion model, that is our RK model, includes three independent emission submodels. That is our the NOx formation submodel based on the Zeldovik scheme. So this is developed by this Zenovop, the researcher name. The soot formation submodel developed by Reslistive, and the advanced NOx formation submodel based on the detailed kinematic mechanism (DKM) for correct prediction of NO emission in the engine. So soot and NOx formation process are simulated with separate procedure after combustion modeling, and the main equation of the RK model were derived by this relative in 1990 to 1994. Between this method afterward was modified and complemented by the Kulshev. Lot of paper if you search in the area, diesel RK related paper. So this Kulshev is already published more than I think 20 papers related to this in a good journals. So the RK model takes into account condition of evolution of each fuel spray and near wall flow generated by sprays, and also interaction between sprays and solve. So as well as between near wall flow formed by adjacent sprays also. So these features of the RK model allow prediction of diesel combustion and emission over the whole operating range for the following other parameters also, like your piston ball shape and sprayer location. Swirl intensity is also there. Then diameter and number and the direction of sprayer nozzles, and the injection profile shape, and any multiple injections. uh, Dr. Rao, can you go to previous slide? I think there is a one history of this. One more. This one. Okay, correct. So when it will started, and what are the main what were the main landmarks of this diesel RK? So diesel RK software core has been started in 1981 to 82. Okay, in the Department of IC Engine and in the Moscow State Technical University. So this from its very beginning, the software was devised as a tool for optimization, research, and other purposes also. So in this time, the software adequacy has been tested to fit dozens of engines of various types and the purposes, different purposes. So many computational procedure and options were introduced into the software to suit the demand of industrial enterprises and the software user, including biggest engine manufacturers of in the country, I think Russia. So the software is intended primarily for IC engine developers and researchers. Hence, much attention is given to provide the product of convenient use for an engineer. So the input and output data therefore are organized in a way to suit the industrial demand. So the first software version with a convenient interface and function of multi-parametric optimization was issued in 1991. Okay, so to whom this the project leader is truly grateful. This the name is A. Surin. So the first diesel software was in use among the leading motor manufacturer of Russia because of its convenient interface and core with the realized and it at that time modern combustion model of the CI engine. So in 1993-1994, based on the novel computational code of mixture formation and combustion in diesel, that developed by this professor Kharkov Polytechnic Institute, and a new software generations was developed and issued Diesel 4T software and its modification Diesel 2T. So for two-stroke, for Diesel 2T, and for four-stroke, Diesel 4T. So the program were equipped with a window interface reminding of window applications by appearance for visualization of the mixture formation process and combustion in a diesel fuel. The jet visualization code was included in the Diesel 40 software. In the late 90s, the remote access to the software via internet was also organized. So the software was intensively used not only within industrial enterprises but in the education purpose at the department of this IC engine and the different university also. So in 2002, so start of this development of the new window anti-oriented diesel RK software. So in this, the software core was considerably improved and included the up-to-date procedure for calculating toxic emissions with account of the exhaust gas recirculation system, multi-phase injection research, and as a result, hard work of the workers team, the first version of Diesel RK software has been issued in 2004. So it was started in 2004, and this as a professional product, Diesel RK software can be successfully used by the beginners, students, and the PhD students of higher schools, higher universities. So to make the process of numerous input data setting this empirical coefficient, maybe day by day they are trying to do setting easier. So this the software comprises specific tools, that is our setting wizards. So the wizards will create data files automatically on the basis of the most general information on the engine to be this studied and using common technical solution accepted in the motor building industry. So the process of input data setting is considerably simplified, and the most elaborate stage of computational research, that calculation model calibration, is also simplified. So the later fact is a special importance to student having little experience, time, and experimental data for customizing the software with the engine. So over the course of its development, diesel software has been always using advanced mathematical models of combustion in a diesel. And in the present software version, the RK model is realized, taking into the account specific injection features and fineness of fuel spraying. That is also important. So in this case, the model accounts for conditions of each fuel spray evolution and thus generated near wall flows as well as their interaction. Next, this we have already discussed. This yes, in this slide, just you can check this DT power. Yes. So this thermodynamic engine simulation tool, that there are basically, I told you this is GT power, then your boost is AVL is there, then LMS international and wave is there. So we are discussing this diesel RK. So what is the main advantage of this diesel RK is the fast simulation, and there is in this software we can do optimization also. And for we are talking if the CFD, so CFD will take the more time because it will do the first meshing, and most of the researcher is doing 50% or more than 50% of the time only the creating the geometry and the doing the meshing, because without going to the in the CFD. So at that time, we have to spend more than 50% of the time for only creating the geometry and the doing the meshing part. So that is the main advantage of this software, this diesel RK. We can do fast simulation and it will take less time also. And for the optimization of combustion, we can do optimization also in this with the help of this diesel RK software. Yes, next. So, what are the main properties which are required when we are doing the simulation in the this diesel RK? Basically, this table are presented for setting of engine operating modes and for calibration of the engine model. For correct calibration of engine model, it is necessary to specify data for several engine operating points with different engine speed and loads, and the preprocessor of the code automatically offers only those data which are necessary for a chosen configuration of engine and configuration of its simulation. So these are the main properties other than if we are doing other than diesel. So these all are properties which we require for, suppose if we are doing some blending, micro algae and other than also edible oil, non-edible oil, whatever we can do. But before that, we have to know that all the properties for the input data as a input data. So this document has not functions of the preprocessor. Therefore, the list of input data includes only data for conventional diesel engine. Okay, at working in the at condition at the sea level. So these are the main data is required for the if we are using other than diesel, then we have to know all this property. Otherwise we can't do the this simulation process in the diesel RK. Yes, next. So this is a line diagram of experimental setup, that is multi-fuel variable compression ratio. In this, the compression ratio is vary for SI engine, that is our 5 to 10. Then for CI engine, it's 15 to 20 or 16 to 20. So in this engine, generally I am doing this experimental work. Then after that experimental, I have to do the some simulation in the diesel RK for validation point of view. So for that, I have to do some input parameter. I have to know that is our line diagram of experimental setup, that is multi-fuel variable compression ratio. So this is very advanced research purpose only, that is used by the only PG and PhD student. That the engine is not for UG students. Yes, next. So this is the actual picture of this engine. That is our different nomenclature is also there: flywheel, dynamometer, calorimeter, then temperature sensor. There are 4 temperature sensor is there for calculating the temperature at different points. Then cylinder head is there. This is the actual picture in the this engine is related to Legion brother. Uh, we have purchased, I think, 5 years back in 2015 in NIT Manipur. Next. So this graph shows the validation with the experimental data. As I told you, there are 2 types of validation. The first one is when we are doing the experimental and compare with the simulation result. And the second one, someone other researcher is already done in last few years back. So we have to take that experimental data and doing simulation or validation or comparing with this experimental result with the our numerical result. So this experimental procedure was conducted on the premises of this advanced IC engine lab, that is our NIT Manipur. And then the atmospheric pressure was 1 bar, and the average temperature during at the time in the March and June, it was 24 degree. So the initial swirl ratio is kept constant, that is our 1.5. Air fuel ratio is around 0.98, and this non-consideration of EGR is taken into consideration for the this validation. So the experiment is also conducted on a test engine, single cylinder, naturally aspirated, water cooled, direct injection diesel engine using diesel fuel with variable compression ratio. As I you can check also in the diagram, there is a three different ratio, compression ratio, that is our 16.5, 17.5 and 18.5. Compression ratio is nothing, your total volume divided by clearance volume. So at I am taking this engine speed is 1500 rpm, that is our constant, and that different engine load also. I have to take this 20%, 40%, 60%, 80% and 100%. So in this, the nozzle opening pressure is 220 bar, that is also constant, and the last one is advanced injection timing, that is our 23-degree crank angle before TDC, BTDC. So in this, to validate the results of this obtained from the experiment and this your I have shown only 6 graph which is related to experimental work performed by me, and which a single cylinder variable compression 4-stroke, and the corresponding comparison of this 6 parameters such as your cylinder pressure, heat release rate, brake thermal efficiency, then maximum pressure rise, exhaust gas temperature is shown in this figure, and this table shows the comparison of error deviation at full load. I am showing only the full load table, that numerical results and the experimental result is as there are 7 parameters: cylinder pressure, heat release rate, brake thermal efficiency. If you check this error deviation, so there is a very less error deviation when we are doing this diesel RK and experimental results. So basically there is a first type of validation. In this validation, the experimental which we have done by ourselves and the compare with the numerical software, that is our diesel RK. Then second, please change. So in this validation with the experimenter, I have taken one researcher Puhan, and the paper is published I think 2009. So in that 2009, in this the condition is with constant injection timing, that is our 23-degree before TDC, and the nozzle opening pressure is 200, 220 and 240 bar. It was taken by the Puhan et al. And the result shows this different 4 diagrams, variation in experimental and numerical work. That is our parameters is cylinder pressure, heat release rate, and brake thermal efficiency and specific fuel consumption. So again, in this table, you have to check this comparison is very less, so we can do this diesel RK software. It is a good agreement with the numerical and your experimental. So these two figures means the previous one and this figure shows that it is clear that the numerical results are in a good agreement with the experimental value. So this proposed numerical solver, this diesel RK, can be effectively used for analysis of this combustion, then performance and emission parameters at different operating parameters also, and we can change the biofuels also. Yes, next. So these are the basic equations which are using for this diesel RK. Some mathematical, I have not shown all the equations. So some mathematical equations is there. The first one is a conservation of energy. Then second one is your ignition delay period. The first ASA means you are the calculating of auto ignition delay period by this pre-mixed combustion period of model. Then third one is a pre-mixed combustion period, the heat release rate by this control combustion. Then in this mixing control combustion phase period at heat release rate can be given this third equation, right hand side. And the last, that one is a burning period model. In this burning phase period related to heat release rate is given by this equation, the last equation, right hand side, the last one. Then next is, please next, NOx formation model is there. Just change the slide. So in the NOx emission, this one, so the NOx emission produced within the combustion chamber in diesel engine, are grouped in form of nitric oxide and nitrogen dioxide. So the NOx emission calculated by chain this Zeldovich mechanism that I have discussed, based on the 18 species are calculated on every step, and the overall system of equation contains 14 equilibrium equations, 3 material balance equation, and the Dalton equation of partial pressure using this all equation, this O2 then twice times of oxygen. So these 5 equation is related to our this NOx formation model. Then Hatridge smoke level model and soot formation model. This formation of soot in the diesel engine due to unburned hydrocarbons possesses a great health hazard and environmental pollution. So the level of soot formation can be calculated using Hatridge smoke level, which is given by these two equation, Hatridge smoke level, and then smoke, that is our BSN model, and PM emission is there. So PM emission by this Alcides method is selected for calculating the particulate matter emission, which is given by equation this one. And the PM emission consists of list of species. Soot has a dominant fraction. So PM emission is a function of soot emission. Then last is summary of emission. So in this, most important emission parameter is summary of emission. It is given by this equation, and in this equation, this constant J equal to 0.15 and L equal to 7. So there are a lot of nomenclature is required for this equations. Next. This heat release rate model, it is very important when we are talking about the combustion parameter in the SI engine and spray tip penetration. So heat release rate model, this distribution of fuel in each region during the spray period shown by this figure. So the fuel is sprayed into two stages. So before jet impingement and the after impingement. So before impingement, there is a first the dense conical core. The second one, the first one is a dense conical core, then the second one is a dense forward front, and the third one is a dilute outer sleeve. And after impingement, there is a 4, 5, 6, and 7. So the fourth is the axial conical core of the NWF, the dense core of the NWF on the piston ball surface, the dense forward front of the NWF, and the last, the dilute outer sleeve of the NWF. As we have already seen, the governing equation are taken into consideration in this model and used for calculation of heat release in the cycle. Since the combustion of a fuel in IC engine occurs in different phases, so these are the main before impingement and the after impingement. And the next is spray tip penetration. So the current position and the velocity of elementary fuel mass, that is our EFM, injected during a small time step and traveling from the injector towards the spray tip it is related in this figure also. And the equation, this equivalent equation is given by this V1 by V0, 2 by 3, this one. So it is the current velocity of EF1, where this VI, it is a current velocity, means your elementary fuel mass. This is EFM. So what are the main principle of this spray modeling, this spray tip? So the theoretically background of the model is based on the method developed in which the fuel spray injected into the combustion chamber of the engine and is split into a number of specific zones. So this is caused by the necessity of detailed account of the following fuel spray evolution. The following means some the different points are there. So first is the difference of fuel droplet evaporation condition in different spray zones, the fuel redistribution among zones in the process of free spray movement and in its interaction with the wall, then interaction of fuel sprays with the walls of the piston bowl and the possibility of fuel hitting in the cylinder liner and the cylinder head surface. So these are the main points for the spray tip penetration, and this spray tip evolution passes through three stages. The first one is the initial formation of dense axial flow, then main stage of cumulative spray evolution, and the third period of spray interaction with the combustion chamber walls and the fuel distribution on the walls. So these are the main three stages for this spray evolution. Next. So, as we know that there are basically three types of engine characteristic, that is our performance, combustion, and emission. So, in this some definition, I have to discuss small definition related to performance, and the next slide is related to your combustion and then emission. So, this characteristic, when we are talking the basic design and thus performance parameter in IC engine, it includes the compression ratio, then swept volume, clearance volume, power input, output and indicated power, thermal efficiency, IMEP, that is our indicated mean effective pressure, BMEP, that is our brake mean effective pressure, SFC, specific fuel consumption, and many more. So these factors include altitude, temperature, and humidity. So the aircraft engine performance decreases as altitude and temperature increases. So in the case of high humidity, the volume of air available for combustion is reduced. So it will causing losses in power in the IC engine. So in this, I have discussed only three parameters. I think this BMEP, the mean effective pressure, is the quantity relating to the operation of reciprocating engine, and it is valuable measure of an engine capacity to do work that is independent of engine displacement. Then volumetric efficiency. The volumetric efficiency is related to ability of the breathing. It is showing the ability of breathing capacity of the engine. Then your exhaust gas temperature. So exhaust gas temperature is diesel engine exhaust gases vary with speed and load. So high loads and high speeds results in the highest temperatures. Generally, the temperature of this 500 degree to 700 degree are produced in the exhaust gases from diesel cycle, and this is our 100% load. It is for no load, it is I think 200 to 300 degrees Celsius. So in brake torque can be attached longitudinally or transversely to the chassis. The torque table describe the amount of torque the engine can deliver the current RPM and for a given amount of throttle. I think it is okay. The next in the combustion parameter, change the slide. In this combustion, there are four major parameters: this ignition delay, cylinder pressure, combustion duration, and heat release rate. So this ignition delay, what is ignition delay? This is in a diesel engine, as the time interval between the start of injection and the start of the combustion, that delay is called ignition delay. This delay period consists of a physical delay, then atomization is also there, vaporization and mixing of air fuel occurs. So other than this, chemical delay is also there. It is attributed to the pre-combustion reaction. Then cylinder pressure is there. So it is the pressure in the engine cylinder during the fourth stroke of the engine. That is our intake, compression, combustion, and expansion and exhaust. We know that expansion process is our power stroke out of four. Then cylinder combustion
Hello, hello,
the heat release rate is the rate at which fire release energy. This is also known as power. So HRR is measured in units of watts, which is an international system unit equal to 1 joule per second. The next last is combustion performance, and the last emission. So in the emission parameter, change the slide. In the emission parameter, there are mainly 5 6 parameter: carbon monoxide, nitrogen oxide is NOx is there, HC hydrocarbon is there, smoke emission, then PM emission. This is our particulate matter is there. So in carbon monoxide is the product of incomplete combustion in IC engine. But when there is not enough oxygen for the combustion process, that is our carbon monoxide forms, that is incomplete combustion. So CO reduces the ability to carry oxygen in the blood. So at high concentration, it may causes to death also. Then NOx, in the exhaust of IC engine, NOx refers to a class of compounds called nitrogen oxide. So in the diesel engine exhaust, this nitric oxide is usually the most abundant nitrogen oxide and constitute more than 70 to 90% of total NOx at engine out conditions. Then hydrocarbon is there. So in hydrocarbon, unburned hydrocarbon are the hydrocarbons emitted after petroleum is burned in an engine. So when unburned fuel is emitted from a combustor, the fuel emission is caused by fuel avoiding the flame zones. Then smoke emission is there in the diesel, black smoke appearing during disturbance in the high pressure pump injector and at a high angle of injection. And then last is your PM emission is there. So exhaust particulate matter is the most complex of exhaust emissions. So PM is defined by most emission standards, and it is a filterable material sample from diluted and cooled exhaust gases. So PM contains a large portion of the polynuclear aromatic hydrocarbon, that is the strong form is PAH, and it is found in engine exhaust. The next, in the next slide, actually this is a performance of diesel combustion model. As I told you in the CFD, it will take a lot of time to do one simulation process. It will take 1 week also for a normal combustion, because the iteration process we can handle a lot of equation. But in the diesel RK software we are doing, it will take very less time to complete the simulation in the diesel RK. So for comparing in the other software, there is a maybe in the AVL and other software, there is no optimization technique. But in this diesel RK, there is optimization tool is also there. So it will take less time. Within 1 minute or 2 minutes also we can do, and it will not take off more than 1 week or 1 month also if you are doing the dynamic machining in CFD. So it will take a lot of time to do complete one simulation also. Next. So now I'm discussing the result and discussion when we are doing this with the help of diesel RK. I'm doing some papers published in this area. So this in this basically I have done first validation, and then I'm showing some equations also. So in this I have tested this diesel and 5 different category biodiesel, that is our edible, non-edible, animal fats, waste oil and alcohol. So that I have taken this mainly exhaust gas emission characteristics only in this case study. So the study was carried out in advanced SY of 23 degree CA, and that is our before TDC, with constant FI of 220 bar at different engine loads. And the speed I have to take constant, that is our 1500 RPM, and so compression ratio is 17.5. So in this emission characteristic, the such as I have to take this NOx emission, smoke emission, PM particulate matter is there, and the summary of emission is discussed. So the first is NOx emission with a different engine loading. There are 5 diagrams. So NOx emission, the nitric oxide emission and NO2 are emission generated during combustion process due to reason of oxygen and nitrogen at high temperatures. So the main reason of NOx emission produced in the combustion process in oxygen present in the free air. So the regular fossil fuel have a trace amount of nitrogen molecules in their structure, but the nitrogen content within the fuel have the effect of nitric oxides emissions. So the NOx emission depends on the combustion cylinder temperature, pressure, air fuel ratio during combustion process, and properties such as our viscosity is there, then bulk modulus and humidity also affect the NOx emission. So the NOx emission shows a reduction with increase in humidity of air. So the biodiesel blends of B 20%, as I told, we can use up to blending of 20% without any modification of the engine part. So B 20 produce lower NOx emission due to a calorific value and viscosity of biodiesel fuel. And the NOx emission are the destructive pollutants produced by diesel engine due to the flame temperature and the oxygen percentage within the fuel and the time of a reaction process. So in this, there are five categories: edible, non-edible, animal fats, and waste oil and alcohol. So it was observed at the full load that the NOx was produced to be at some different values is there. And then the fraction of wet NOx is exhaust gas is lower by around 20% or maybe 21% for the soybean biodiesel. So this NOx increases with increasing load of engine at all tested fuels, and it can be observed that the NOx emission is depends upon the temperature of engine cylinder, percentage of oxygen, and the time taken for reaction to take place during combustion. So the most affected on NOx emission by using of this out of this five category, that is our soybean, then jojoba, then chicken fats and grease oil, and the last is alcohol and butanol is there. So in the, please next. There is a PM emission with a different engine loading. The PM emission shows a reduction in the biodiesel and its blend with diesel fuel, which may be due to higher percentage of oxygen content and better oxidation of air and fuel. The main factor of this PM emission is improper fuel burning within the combustion chamber in the fuel rich section. So the complete combustion leads to the this production of PM due to the higher oxygen percentage within the biodiesel, and the advanced injection timing lead to higher combustion temperature, and it helps in reduction of PM emission. So the PM and NOx emission reduces with increase in surface tension of fuel while improving combustion process. So again in this there are five categories: edible, non-edible, animal fat, and waste oil and the alcohol. So it can be observed from the that graph that PM emission decreases with increases in engine load. The fraction of specific PM emission in exhaust gas is lowered by around 40% for coconut biodiesel, and we have to compare for all this different categories by the as compared with the diesel only. So the PM emission reduction with increasing load of engine has been calculated for all the fuels, that is our different category, and some alcohol biodiesels give negative effect on PM emission, which is clear from the test alcohol. It is you have checked in the fifth diagram. This coconut oil, microalgae, and poultry oil has great effect on the PM emission as compared with the other biodiesel. Next. Smoke emission is there. So in the smoke emission with different engine loading, so the smoke emission measured in BSN are typically caused by an inadequate supply of air during combustion phase, during engine acceleration, and a lower temperature of combustion zone. So the complete combustion shows reduction in soot formation emission due to the oxygen content in combustion phase. So in this, the smoke emission at a different engine load for the different category of biodiesel, this five diagram shows, and it can observe from the graph that smoke emission decreases with increase in engine load. So the fraction of specific smoke emission in exhaust gas is lowered by around 93% for this sunflower, that is our edible vegetable oil, and for if you are talking about this karanja biodiesel, that is our non-edible vegetable oil, 93%. So the smoke emission reduces with increasing in loading of engine for edible and non-edible vegetable oils, and the smoke emission decreased with higher content of oxygen in the fuel. So the this contribute to complete combustion of the fuel even in rich zone and for different biodiesel like your sunflower, karanja, fish oil, or pentanol biodiesel, it is a we are comparing this all with the regular diesel fuel. The next, this is the variation that summary of emission, that is our PM and NOx. So the summary of emission is important parameter when we are talking about the emission side. So all this graph is related to this summary of emission, that is our SE, edible, non-edible, waste animal fat, and waste oil, alcohol. So all the tested biofuel in this numerical approach predicts lower summary of emission compared to diesel when we are taking this compression ratio 17.5. So it can be observed from the graph, the SE decreases with increase in the engine load, but alcohol increased, only propanol decreases in the, if you are taking in the last graph, the total summary of emission in exhaust gas is around 4% for soybean, and this for other biodiesel also, this is for 40% for the, I think, wheel oil biodiesel, that is our waste animal fat, and it reduces with increasing in loading of engine for edible and non-edible vegetable soil. And basically these all are related to our diesel RK software. We are doing the numerical work in this, so it is very helpful to do through this numerical diesel RK, because for experimental we have to purchase this experimental setup, and it is very difficult because the setup is very costly also. Around, I think this Legion Brother engine is around more than 10 lakhs, and for every institute or for every student it is not possible to purchase also. That is very uh, difficult to purchase for this engine. And other than this, when we are taking this experimental, if we are going to the experimental side, so you have to take some centralized facilities also, like your GCMS, FTIR, SEM images there, because we have to purchase or we have to produce this biodiesel first, and then we can do the blending. And before that, this blending we can do by hand also, and by magnetic stirrer is there, so we can do blending in the magnetic stirrer also. Studies says up to the maximum 20% of the biodiesel we can use directly into our engine without any modification. After 20%, if we take the biodiesel percentage is around more than 30 or 40%, so we can do some modification in the engine. So now studies is maximum or this optimized value is B20%. So these all are related. These results I have shown only for the emission part. With the help of diesel RK, we are doing this results. We have achieved this result, and this paper is already published in a very good journal. I think it is in ECM, Energy Conversion and Management. The impact factor is around more than 8. And this is, if we are taking this diesel RK, as I told, the timing of this if we compare with the other computational software like your CFD, AVL, and Boost. So CFD gives some comprehensive information like in the form of contour, in the form of vector, or some particle trajectory is also there in the CFD. But these facilities are not available in the diesel RK. It will give you, it will give you in all the values in the, we can export in the Excel form, then we can draw this results. We can plot in the any good plotting software. So the comprehensive results, it is not given by this diesel RK software. That is the disadvantage or some errors is error point of view. We can say some contour is not there, then your vector plot is not there, then some particle tracking is not there. So that is the disadvantages of this software. But other than this, it will take very less time, and for this also we cannot take any workstation. So it is, workstation is not required for this diesel RK software, and it is available for internet also. It is easily available. You can take this download from the diesel from the internet. Uh, Next slide in the conclusion. So it can be, okay, sorry, for this slide, summary of result for different biodiesel fuel at constant speed with full load, as I categorize this emission parameter in the edible, non-edible, then your waste and the waste oil, and the last is alcohol. So these are the values which I have shown in this table, that is our NOx, then PM, then smoke, and summary of emission. So you can check the results part. Next. In this slide, I have shown the least pollutant formation among all the biofuels. I have taken around more than 20. So you can check in this. I have taken only biodiesel, like in edible soybean, palm oil. Then in non-edible, there is a jojoba and microalgae. Microalgae is now it's a very energetic area for biodiesel. Then there is an animal fat, chicken and lard. Then waste is oil is there, grease oil and cooking oil. And then alcohol is there. Then that is our butanol and pentanol. And the last one is our fossil fuel, that is our diesel fuel. So in this, I have taken only two biodiesel. In the previous slide, I have taken all the values I have shown. This is just a small
हेलो
condition for
ये
this.
किस हिसाब से है ये ना 3,07,000
Which one? This NOx ppm?
नहीं इसके पहले जो 13-13.5 लाख रुपए दिए हैं
13 lakh. Please go to previous slide.
अभी जो क्या कहते हैं अपने 2.5 लाख दिया था वो इंक्लूडेड है अच्छा
Okay,
मतलब
I think
31 साल
someone is
और
talking
31 तक करा
some
दिया
other.
जाएगा है ना
Dr. Rao, please go to
Hello.
hello.
Sir,
Hello.
you can carry on. You can carry on, sir.
Okay. Please go to next slide in the conclusion part. Next. Yes, in this can be concluded by emission results that under the unvarying operating condition for this minimal pollution, in this there are 5 different categories of biodiesel, that is our edible, non-edible, waste oil, alcohol has been tested for producing power of IC engine and produce lower NOx than PM and smoke emission, which already we have discussed in the previous slide, compared to when we are comparing to the regular diesel fuel. So this is conditions emission for soybean, jojoba, microalgae, leaf fats. This affects emission reduction
Hello.
within combustion chamber in diesel engine.
Hello.
Then hello.
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 Sir, please, sir. Carry on.
Okay. So the lowest level of NOx pollutant emission for soybean, that is our edible, and For jojoba, that is non-edible, and chicken fat, animal fats is related to this. And go to next. And this is also related to this case study. The smoke pollutants emission is found to be at least in sunflower are edible by this
Sir, sorry to interrupt.
0.0.
Sir, something has
Hello.
come on the screen. Speaker
But
setup.
my screen is. Hello.
Yes, sir. Speaker setup. Something has come onto your presentation slide.
From my end, I think it is okay. It is clear. The slide is visible only. No one in the slide.
Here it is totally covered. Halfway
Dr.
covered.
Dr.
is
Rao,
okay,
is
sir.
there any problem?
No, sir. It is okay. Actually, speaker setup was there. Hello. Is it?
Yes, yes.
HD sound, IDT, HD sound. Something has come.
No, that is removed, na, sir. Now it is removed. You please check with internet connection. Your
Okay.
internet 1 minute later. Now that
Okay.
is removed.
Okay.
Initially it has come. Now it is okay, sir. Okay, sir. Now it is visible, na, sir.
It is clear. Sir.
Okay.
Clear. I think it is clear. Okay. So for this conclusion, there are this. It was found by the summary of emission that there is a reduction for different biodiesel which I used for numerical work. That is soya bean and jojoba and wheel oil. The values is also given 3.19, 2.8, and other values is also given. Next, I think some references is there. Yes, this is the references. This Petnovic, you can check a lot of paper he have already published with the help of this diesel RK software in the area of this biofuels. Next. Cool shave is there. It is. It was given some important mathematical expression related to this Rizal RK. Yes, thank you. So any question from the audience?